Okay, geometry, chapter 12, section 6. Spheres, surface area of spheres. When we talk about spheres, we are going to be using terminology that is identical to circles in many ways. So let's look at the picture over here. Radius of a sphere, just like the radius of a circle, it is going to be the distance from the center of the sphere to a point on the sphere. You know that a sphere is a ball. I hope you know that. A chord, just like in a circle, a chord is going to connect 2 points on the sphere. So that's going to be a chord right over there. Diameter. Diameter is going to be a special chord. It's going to be the chord that goes through the center of that sphere. So like any chord, it's going to connect 2 points on the sphere. It just happens to go through the center. So that's going to be the longest chord, the diameter. And a tangent, just like on a circle, a tangent is going to be a line that intersects the sphere, instead of a circle, in exactly 1 point. There'd be a point of tangency right over there. If you think of a ball sitting on a desktop, that ball is tangent to the plane of the desktop. Formulas. We're getting near the end of our formulas in your formula sheet. Surface area of a sphere, 4 pi r squared. 4 times pi times the radius squared. You remember the area of a circle is pi times the radius squared. So let's see if we can use that formula and get some answers here. 1A, guided practice 1A, they find the surface area of the sphere. We're going to use our formula, write it down each time so that we help memorize it. So when the test comes along, we know our answer very well. So as simply as 4 times pi times our radius. They told us it was 7.1 millimeters. We're going to square it. You'll run that through your calculator, rounding off to the nearest tenth. 633.5 millimeters square. Make sure you're using the pi button. You're not using 3.14 so that we get as accurate a picture as possible. 1B, surface area of a sphere, 4 times pi times the radius squared. 4 times pi times, what's our radius? 11. I could hear you all say it all the way to St. Louis or wherever I am right now. So 4 times pi times 11 squared, rounded off, 1,520.5 feet square. Hopefully some of you are checking me so that if I make a mistake, you can say, no, it's supposed to be this. Hopefully I didn't make a mistake. When we take a sphere and intersect that sphere with a plane, so you can see down here we have this plane. It's possible to intersect a sphere in exactly 1 point. It's tangent. That's like the ball sitting on the surface of the desktop. It is possible for us to intersect a sphere moving up into the circle a little bit. And if you move up into the circle a little bit and you intersect it, you are going to get a circle as the points of intersection where that plane and that sphere would touch each other. It would be a circle. If you move your plane up so that it goes through the center of the sphere when you intersect, then this is the largest circle you can get. The largest points of intersection is called a great circle. That's going to be the largest circle when you intersect a plane and a sphere. And the ends of that diameter that you would be going through, you can see they call them poles. Just like if we're talking about the Earth, we have a North Pole and a South Pole. So the poles would be the endpoints of the diameter. I guess that disappears behind. I better not move that around. And when we take a circle or a sphere and intersect it through the diameter, we cut it exactly in half and get a hemisphere. Half of a sphere. Find the surface area of the hemisphere. Now they're talking about just the bubble part, the circular part, not the flat bottom there. Well, if I have the surface area formula for a sphere being 4 pi r squared, And now I have a hemisphere. Hemisphere is half a sphere, so we are going to have half of that surface area of the sphere. Well, if I take half of 4, that gives me 2 pi r squared. So 2 times pi times our radius, they tell it was 2.8. We're needing to square that. Running it through your calculator, rounding to the nearest tenth, 73.9 centimeters squared. This isn't hard enough to be called geometry, sophomore level, but just enjoy it, I guess. Find the surface area of a sphere if the circumference of a great circle happens to be 5 pi meters. Well, if it is a great circle, we know that the circumference of that great circle is exactly the same thing as the circumference of the sphere, because we're going right through that diameter, right through the points, the chord that would go through the center. So if I have the circumference of the circle that we are told, 5 pi, well, the circumference formula for a circle, 2 pi r, 2 times pi times the radius. So if my circumference is 5 pi, let's substitute. 5 pi is the circumference equals 2 pi times the radius. We can use this to get our radius. Divide by pi, that'll disappear. Divide by 2, 5 over 2, or 2.5, that is our radius. So now I can use that to come back and figure out the surface area of my sphere. Surface area of a sphere, 4 pi r squared. 4 times pi times our radius. We just figured out it was 5 over 2 or 2.5. Can be written either way. Needs to be squared, whichever way you write it. Multiplying it through on a calculator and rounding to the nearest tenth would be 78.5 meters square. Let me do something a little bit. Let's do the exact answer first before we get to that decimal. If I squared that fraction, 4 pi, you square that fraction 5 over 2, where you square the 5, which is 25. You square the 2, which is 4. Then if I go to multiply here, those 4's would cancel. Pi times 25, or 25 pi. 25 pi meters squared would be the exact surface area of it. And then sticking it into your calculator, 25 times pi rounded to the nearest tenth, 78.5 meters squared is what you should be getting. Should be able to do these exact values. We do that from time to time. So just leave that pi value there and simplify the numbers. Proceed. Find the surface area of a sphere if the area of the great circle is 130 square inches. So the area of that circle, well, again, we need to figure out the radius of that sphere, which would be the radius of that great circle. So if I'm talking about the area of a circle, area is pi r squared for a circle. Area is 130. Replacing or substituting, 130 equals pi r squared. So I want to solve for my radius. Divide by my pi, 130 over pi. Make that pi equals our radius squared. I want the radius instead of radius squared, so I'd have to take the square root of 130 over pi. You should try that. I'll give you just a second. I've been kind of running through these fairly quickly. Try that on your calculator. Make sure you can get the correct value with that fraction inside that square root. Rounded to the nearest tenth, you should be getting approximately 6.4. So if we have our radius, and actually I won't round off to the nearest tenth yet. Let's take it 2 decimal places, 6.43. So if we have our radius, then I can come back and we can figure out the surface area of the sphere. Surface area of a sphere, 4 times pi times our radius squared. So 4 times pi times our radius, 6.43. And if you leave it in your calculator, it's even better. Square that off. Approximate answer, 514.7. Now, I'm not sure if that, and it was in inches, I'm not sure if that was from leaving it in the calculator or not leaving it in the calculator, using some previous notes from last year. Volume of spheres. Let's see if we can figure out a thought process that could lead us to a formula for the volume of a sphere. And here's a thought process that will give us a fairly good idea of how we get the formula for the volume of a sphere. If you take a sphere and you are able to cut it up by making little pyramids, the point right here, the vertex of this pyramid is the center of that sphere. Now this outside surface is not exactly flat. But if you made those pyramids smaller and smaller so that it takes more of them to divide up that sphere, maybe you can visualize that as you take a smaller and smaller section of that curved surface, that little piece of the curved surface gets more and more flat. We have a special term for that in math. We're finding the limit of that surface as its dimensions go to zero, as it gets smaller and smaller and smaller. And the smaller you get, the more flat it is. So these little pyramids, if we found the volume of one of those pyramids and multiplied it by how many pyramids we had, we should have the volume of our sphere. And we know that the volume of a pyramid is 1/3 area of the base times the height of the pyramid. Well, the height of our pyramid is the radius, because that point at the vertex is the center. So we can adjust that formula just a little bit to get this one, 1/3 the area of that base times the radius. And then we want to add all of these together. So one pyramid plus a second pyramid plus however many pyramids we happen to have. So we can have a whole bunch of them in there. Then I'm going to divide or factor out what is common. We have a 1/3 that is common, and the radius. All those radii are going to be the same. So we factor out a 1/3 radius, and what is left is the area of the base. All these little pyramids' base areas is left for inside. Well, if you think a minute about what all those base areas are, if we put them together, that's the surface area of the sphere. And we learned the formula for the surface area of the sphere, 4 pi r squared. So 1/3 times the radius times the surface area of the sphere, 4 pi r squared. Multiplying that together, radius times radius squared gives us radius cubed. 1/3 times 4 is 4/3. 4/3 pi r cubed. That's the volume formula for a sphere. So I hope it kind of makes sense to you now. Where did that come from? Well, this is an idea, kind of a geometric approach. There's a calculus approach as well. But this is a geometric approach that can kind of help you understand where does that volume formula come from. So memorize this. 4/3 pi r cubed when we're talking about volume. And remember, volume is a 3-dimensional unit. So that's why the radius is cubed there. So we'll have centimeter cubed or inches cubed or something like that. Find the volume of each sphere or hemisphere, and they want us to round to the nearest tenth like we have been doing earlier. So part A, a hemisphere with a radius of 6 meters. Well, no problem. Volume of a sphere is 4/3 times pi times the radius cubed. Since we have a hemisphere, we have half of that. So we can adjust our formula a little bit. 2 goes into 4 twice. So if I simplified that, I now have 2/3 pi r cubed. Instead of 4/3, we have a hemisphere, half of it. So filling it in, 2/3 times pi, our radius is 6, that 6 has to be cubed. You run it through your calculator, and your calculator is going to tell you approximately 452.4. And the measurement or units was meters. Almost wrote meters square. We're a volume, meters cubed. Now this one could also be done in an exact value. Looking at the exact value for a minute. If I have 2/3 times pi times our 6 cubed. Well, our 6 cubed, I need to figure out what our 6 cubed is. I didn't do that ahead of time. Our 6 cubed is 216 times 216. So now I can reduce. 3 goes into 216. We need to know how many times 3 goes into 216. Divided by 3, 72 times. So I have 2, so it goes in 72 times. So I have 2 times 72 times pi. 2 times 72 is 144 pi. There would be the exact value. And if you try it on your calculator round to the nearest tenth, hopefully it equals that previous answer that we had just a minute ago. B of that same problem on the next page. We're trying to find volume. Volume of a sphere with a great circle circumference. Great circle circumference, 18 pi centimeters. So we know if it's a great circle, the radius of that great circle is the same as the radius of our sphere. So we'll figure out the radius by going back to a circle. Circumference of a circle, 2 times pi times the radius. So if our circumference is 18 pi, 18 pi must equal 2 times pi times our radius. Let's divide by pi, divide by 2, there's our radius. So what's the volume of our sphere? Formula, 4/3 pi r cubed. Substituting values, 4/3 pi times our radius cubed. And 3,053.6 centimeters cubed. Hopefully whichever students were telling me these answers last year were using their pi button, and so we're getting the right answer right down here. World Cup soccer. I know a lot of you are probably soccer fans. The soccer ball globe at the right was constructed for the 2006 World Cup soccer tournament. It takes up 47,916 pi cubic feet. There they have given us an exact value of space. Assume that the globe is a sphere. What is the circumference of that globe? Well, if I'm trying to find the circumference of a globe, I need to figure out what the radius is. The radius of the great circle. Then we know circumference is 2 times pi times the radius. So since we know the volume, 4/3 pi r cubed, we can figure out the radius, come back and put our radius in our circumference formula, and we'll get the circumference of our globe. Volume, 47,916 pi must equal 4/3 pi r cubed. Well, we can divide both sides by pi, and that is gone. How do we get rid of the 4/3? I hope I am hearing multiply by the reciprocal, which is 3/4. That would get rid of the 4/3, multiplying by the reciprocal. So this will give us our radius cubed when we are done. So let's see what we get. If we take 3/4 times 47,916. 35,937 is what I'm getting. I want the radius. I don't want the radius cubed. Cube root. If I had the radius squared, I'd take the square root. I need to take the cube root of 35,937. Now, all of your scientific calculators can handle different roots. Square roots, cube roots, fourth roots. Some of your calculators may even have a cube root button. That little 3, the index in the corner of that square root sign, which is really a radical sign. Cube root. So maybe you have a cube root button on your calculator, and if you do, you can just use that button. If you don't have that cube root button, you will have, and even if you do have it, you will have an X root button, a little X in the corner, which means I can take any root. So you may have to look a little bit to find that. So if I was trying to take the cube root of something, I'd first tell it 3, and then hit my X root button. I have told it it's going to be a cube root, and then we'll enter our 35,937. And then we'll hit our equal. Better hit our button down here, equal or answer or whatever you happen to be. Now I'm going to have to do that. Find my cube root button. 35,937. The answer you should be getting is 33. Exactly. So there's our radius, not our final answer. That is simply our radius. But now we can get our final answer, the circumference of our circle. Circumference of our circle is 2 times pi times our radius of 33, which would be 66 pi. What did they say? Did they say to the nearest tenth? Don't know if they said to the nearest tenth or not. We'll go to the nearest tenth. 66 times our pi is going to give us 207.3. Meters, feet. Measured in feet. So there's the circumference of our circle. Your assignment. You'll have to do some of that we normally do together, working as a class without the teacher here, but you guys are smart. Page 884. Your assignment will be numbers 1 through 38.